Good evening, everybody. So we begin with sum number 20. Show that the height of the cylinder of maximum volume that can be inscribed in a sphere of radius r is 2r upon root 3. Also find the maximum volume. You will notice that we have already solved this sum. You have to refer to question 20 of which exercise? Exercise 2.4. I'll show you that sum. We had done that. See, this is the sum. The sum was framed as find the volume of the largest cylinder that can be inscribed in a sphere of radius r. So in that we proved, see, h equal to 2r upon root 3. Now in this sum, same thing is asked, that for maximum volume, height is 2r upon root 3. Also find the maximum volume. So this is the maximum volume. Okay, good. Now the last sum, that is 21st sum, find the maximum and minimum values of the function f of x equal to cos square x plus sin square x. So start solving. Fx is given. What is f dash of x? What is derivative of cos square x? It is 2 cos x into derivative of cos x, which is minus sin x, plus what is derivative of sin x? It is nothing but cos x. So basically 2 sin x cos x is sin 2x. So can I say that this is minus sin 2x plus cos x? Yes, it is correct. Find out second derivative. So f double dash of x is nothing but minus 2 cos 2x. Why? Derivative of sine is cos into derivative of 2x, which is 2. You have to remember chain rule. Minus derivative, rather cos x has derivative minus sin x. Okay. Now the next step is f dash of x equal to 0. F dash of x equal to 0 gives, tell me what we get, minus sine 2x, okay, plus cos x equal to 0. What next? Tell me. Okay. So again, I think I should have kept that as it is, but no problem. Minus 2 sin x cos x plus cos x equal to 0. Take minus cos x common, I will say. Minus cos x common. So that gives me 2 sin x minus 1 equal to 0. Therefore, cos x equal to 0 or 2 sin x minus 1 equal to 0. That is cos x equal to 0 or sin x is nothing but 1 by 2. Okay. Now actually there are so many angles, but I will consider therefore x equal to pi by 2 because cos pi by 2 is 0. Okay. And sin x is half, so I can say x equal to pi by 6. That's it. We consider these two angles because there are so many angles having same sine ratio half. There are so many angles having cosine ratio 0. Okay. Let us find second order derivatives at these points. So I first select pi by 2. What is f double dash of pi by 2? We have already obtained second derivative. So f double dash of pi by 2 is minus 2 cos 2 times pi by 2. So minus 2 cos pi minus sine by 2. See, you should be able to do this within few seconds. Now what is cos pi? Minus 1. What is sine pi by 2? 1. So ultimately we get what? We get 1 which is greater than 0. Okay. So by second derivative test, the function has minima at x equal to pi by 2. You have to mention that therefore by second derivative test function has minimum at x equal to pi by 2. Okay, and what is the minimum value? I can say f minimum. F minimum is simply f of pi by 2. Remember, this is value of the function and not of first or second derivative. In fact, first derivative at pi by 2 is 0. So cos square pi by 2. Okay, so this is cos square pi by 2, which is 0, plus sin pi by 2. So this is 0 plus 1 equal to 1. So this is the minimum value. Now consider second point, which is what? Pi by 6. I hope you have finished writing this. So f double dash of pi by 6 is minus 2 cos 2 times pi by 6, okay, minus sine pi by 6. What is cos pi by 3? Half. What is sine pi by 6? Half. So this is nothing but minus 3 by 2, less than 0. So by second derivative test, the function has maximum at which point? X equal to pi by 6. Therefore, by second derivative test, function has maximum at x equal to pi by 6. Also find that max value. F max is f of pi by 6. So cos square pi by 6 plus sin pi by 6. Tell me what you get. What is cos pi by 6? Root 3 by 2. So its square is 3 by 4. 3 by 4 plus half, that is 5 by 4. So this is 3 upon 4 plus half, that is 5 by 4. So this is the maximum value of the function. See, this is the graph of which function? This one. Y equal to cos square x plus sin x rather. So this is the point pi by 6. At this point, function has maximum value. Again, at this point also same maximum value. As I have told that there are many angles which have the same value of cosine ratio. Okay. Now at pi by 2, see the function has minima. Okay. And what is the minimum value? 1. And what is the maximum value? 5 by 4, that is 1.25. Okay. Now we start solving multiple choice questions. The first one, if the function f of x equal to ax cube plus bx square plus 11x minus 6 satisfies conditions of Rolle's theorem in closed interval 1, 3 and f dash of 2 plus 1 upon root 3 equal to 0, then the values of a and b are. Logic is very simple. See, Rolle's theorem, all the conditions are satisfied. So can I say that f of 1 is the same as f of 3? Do you agree with me? F of 1 is same as f of 3. Now find out f of 1 and f of 3. Tell me what you get. F of 1 is value of the function at x equal to 1. Find out. Replace every x by 1. Okay. So see what we get. We get a plus b, okay, plus 11 minus 6. And what is f of 3? Value of the function at x equal to 3. Just check this. 27a, okay, plus 9b, 9b plus 33 minus 6. You get one equation. What is that equation? 26a plus 8b minus 22, that is 13a, okay, plus 4b equal to minus 11. Now we need not obtain second equation. Actually there are two unknowns, right? A and b. So to get their values we need two equations. But here if you check options, I think in only one option 13a plus 4b will have value minus 11. So just check the options. See, when you are using shortcut method, you have to be very careful. Means what? Suppose in option A, you see that equation is satisfied. You cannot declare that A is the correct option. Why? Because you will have to verify whether values in options B, C, D do not satisfy this. If they do, then we'll have to obtain second equation. But I think in option A only this happens. Just check it. Only in A. So what is the answer? Correct option is A, Ahmedabad. Yes, Aditya, you are right. I hope you understood this. And somebody will ask, sir, suppose in two options we are getting this, what should be done? Then use the criterion f dash of c equal to 0. Find out derivative. Now 2 plus 1 upon root 3 is the root of that equation and so on. So you get another equation. Good. Now second, f of x equal to x square minus 1. I simplify this function. Otherwise, I will have to use quotient rule. So I write numerator as what? X square plus 1 minus 2. This is indirect division. Okay. So this is 1 minus 2 upon x square plus 1. Now we are solving MCQs, so we need not find second derivative if there is only one root. Okay. This is 0 minus 2. What is derivative of 1 upon x square plus 1? It is minus 1 upon x square plus 1 bracket square into derivative of x square plus 1, which is 2x. We equate this with 0, f dash of x equal to 0. So that gives me x equal to 0. So f minimum, because they say minimum, so minimum. So what is f minimum? 0 minus 1 upon 0 plus 1, that is minus 1. Is this option given? Yes, C is the correct option. Should I explain this again? Okay, I'll. See, you could have differentiated this as it is using quotient rule. Anyway, we use quotient rule, but we can simplify this and then we will use quotient rule. This is indirect division. So we get this 1 minus. Now what is derivative? Derivative of 1 is 0 minus 2 constant. What is derivative of 1 upon v? Minus 1 upon v square into derivative of x square plus 1, which is 2x. We equate that with 0. So I get x equal to 0. So the minimum value is minus 1. Go for Calcutta. Sum number 3, a ladder 5 meter in length is resting against vertical wall, the bottom of the ladder is pulled along the ground away from the wall at 1.5 meter per second. The length of the higher point of ladder when the foot of the ladder is 4 meter away from the wall decreases at the rate of. We have solved one sum of this type. Okay. So this is the ladder AB. Now I take this as X, this is Y, this is phi. So clearly X square plus Y square equal to pi square, that is 25. So 2x dx dt plus 2y dy dt equal to 0. So rearrange the terms. We are interested in dy dt. What is dy dt from this? Dy dt is nothing but minus x upon y dx dt. Now tell me what is given. Now when x equal to 4, because the length of the higher point of the ladder when the foot of the ladder is 4 meter away from the wall. Okay, so x equal to 4, therefore y equal to what? 25 minus 16 ka root, so 3. Also, what is dx by dt? I think it is given to be 1.5. Substitute the values and tell me what is the answer. So this is minus 4 upon 3 into 1.5. So I think it is minus 2. Is this option given? Yes, B Bombay. B Bombay is the correct option. Sum number 3. Yes. Right now. If you have finished third, go for fourth. Okay. Now sum number 4. Let fx and gx be differentiable for 0 less than x less than 1 such that f of 0 is 0, g of 0 0, f of 1 6. Let there exist a real number c in open interval 0 1 such that f dash of c is twice g dash of c, then the value of g of 1 must be. See, we cannot say about Rolle's theorem, but yes, Lagrange's mean value theorem is satisfied. So what is f dash of c? F of 1 minus f of 0 upon 1 minus 0. So that comes out to be what? 6. Similarly, find out g dash of c. So what is g dash of c? It is nothing but g of 1 minus g of 0 upon 1 minus 0. Okay. So this is simply g of 1. Good. Now we are given that they are, what is the relation between them? As f dash of c, okay, equal to twice g dash of c. Can I say 6 must be equal to 2 times g of 1. So what is g of 1? G of 1 is nothing but 3. Is this option given? Yes. The correct option is B, Bombay. Sum number 5. Let fx be x cube minus 6x square plus 9x plus 18. Then fx is strictly decreasing. Now for strictly decreasing function, f dash of x less than 0. Now what is f dash of x? 3x square minus 12x plus 9 less than 0, divided by 3. Now consider x square minus 4x. This can be perfect square of x minus 2. Square this. X square present, minus 4x present, plus 4 not there. So to make hisab barabar, immediately subtract 4. But plus 3 is there right from the beginning. So you have to consider that also. Now we get x minus 2 square less than 1. How to solve this inequation? I have told you at least 10 to 15 times. It is minus 1 less than x minus 2 less than 1. Add 2 to the this, you get 1 less than x less than 3. So this is open interval 1, 3. So the correct option is D, Delhi. If you want, you can. Okay, you haven't finished this? Okay, I'll give you some time. If you want, you can write this down. This is repetition, but repetition helps. X square less than a square means, write down, minus a less than x less than a. X square greater than a square means x less than minus a or x greater than a. झाला असेल तर थांबायचं नाही. सम नंबर 6. Okay. Now sum number 6. If x equal to minus 1 and x equal to 2 are the extreme points of y equal to alpha log x plus beta x square plus x, then find out dy dx. So these must be the roots of which equation? Dy dx equal to 0. So what is derivative of alpha log x? It is alpha upon x. Okay. Plus it will be 2 beta x plus 1. Is it correct? Yes. Plus 1, and we have to equate that with 0. X equal to minus 1, x equal to 2 are roots of above equation. Now put x equal to minus 1 first. Therefore, minus alpha minus 2 beta plus 1 equal to 0. That is alpha plus 2 beta equal to 1. I think you need not obtain second equation. Check options. I think one equation is sufficient. Or you may say, sir, we'll obtain second equation and we'll solve. No problem. But I think values in option C only, they satisfy this equation. Now try remaining sums. Sum number 7. The normal to the curve x square plus 2xy minus 3y square equal to 0 at 1, 1. Options are meets the curve again, does not meet the curve again, meets the curve again. Okay. So let us find equation of normal first. For that, we'll have to find slope of tangent and then slope of normal. Differentiate this. So 2x, okay, plus 2. What is derivative of xy? It is x dy dx plus y into derivative of x, which is 1, okay, minus what? Derivative of 3y square. I write this as 6y dy dx equal to 0. Okay, divide by 2. So this is x plus x dy dx plus y minus 3y dy dx equal to 0. So slope of tangent at 1, 1. First we have to find slope of tangent. So what will be the slope of tangent at 1, 1? Put x equal to 1, y equal to 1. So 1 plus dy dx plus 1 minus 3 dy dx equal to 0. So what is dy dx from this? Dy dx is nothing but 1. Okay. Therefore, slope of normal, remember normal is perpendicular to tangent. So it is minus 1 upon 1, that is minus 1. Normal also passes through the same point 1, 1. So we get equation of normal. Write down. What will be the equation of normal? Y minus 1 equal to minus 1, x minus 1, that is y equal to 2 minus x. Okay, so this is the equation of normal. Now I put value of this y in the equation of the curve to see whether this intersects the curve once again or not. I hope you are getting this. See, at this point normal is drawn. I'll show you. I'm not saying this is the case in this curve, but suppose this is tangent, this is normal. See, normal is again intersecting the curve. Okay, so we have to just verify this. Good. What I have done is okay. Now this is correct. Okay, put this in equation of curve. So tell me what you get. It is x square, okay, plus 2x, and what is y? 2 minus x, right? Minus 3, what is y square? 2 minus x bracket square equal to 0. Now you have to simplify this. Tell me which quadratic equation you get. So x square plus basically 4x minus 2x square minus, so this is 12 plus 12x I suppose minus 3x square equal to 0. Is it? ये बराबर है नहीं. That is minus 5x square. No, this is not correct. Okay, let me see. So this is x square plus 4x minus 2x square. Okay. Then minus 12 minus 5x square plus 16x. Tell me what you get here. X square plus 4x minus 2x square minus 12 plus 12x square minus 3x square. So you get this. Finally, if you divide by minus 4, you get quadratic equation as what? X square minus 4x plus 3 equal to 0. So x equal to 1, x equal to 3. Now when x is 1, what is y? 2 minus 1, that is 1. Therefore, point is 1, 1. Yes, normal is drawn at that point only. Okay. Now, x equal to 3 gives y equal to 2 minus 3, that is minus 1. So what is p dash? It is nothing but 3 minus 1. Now check the options. Yes, normal is again meeting the curve at point 3 minus 1, which lies in fourth quadrant. So the correct option is D. Check this. Correct option is D. Sum number 8. The equation of the tangent to the curve y equal to 1 minus e raised to x by 2 at the point of intersection with y-axis is. Basically, when what is the equation of y-axis? X equal to 0. So put x equal to 0 in the equation of curve, you get y equal to 0. This means tangent is drawn at which point? 0, 0. Now let us find slope of tangent. What is dy dx? It is minus e raised to x by 2 into derivative of x by 2, which is half. So minus e raised to 0 into half, which is nothing but minus half. Are you getting my point? Why I have put x equal to 0? Because I want slope of tangent at x equal to 0. So I will say this is nothing but slope of tangent. Now tangent passes through origin. So equation is y equal to mx. That is y equal to minus half x. So what is the answer? X plus 2y equal to 0. So correct option is A, Ahmedabad. Should I explain this again? Okay. See, the tangent at the point of intersection with y-axis. So let us find that point. What is the equation of y-axis? X equal to 0. So put x equal to 0 to get y equal to 1 minus, because e raised to 0 is 1. So 1 minus 1, that is 0. Means tangent is drawn at 0, 0. Okay. So what is dy dx at 0, 0? Minus half. So what is the equation of tangent? Y equal to minus half x. Right. Sum number 9. What is that sum? If the tangent at 1, 1 on y square equal to x 2 minus x bracket square meets the curve again at p, then p is. See, first I try to use shortcut method that 1, 1 has to lie on the tangent. Okay. And in fact, that point P has to lie on the curve because the tangent meets the curve again at P. But I think in more than one options, we can see that condition is satisfied. So this method is not working. So differentiate. 2y dy dx equal to 3x square minus 8x plus 4. Now derivative at 1, 1. So it comes out to be what? Minus half equal to slope of tangent. Okay. slope of tangent. So what is the equation? So equation is y minus 1 equal to minus half x minus 1. Simplify this. So you get equation of tangent as x plus 2y equal to 3. Now check options. Now check options. I think in option minus 1 plus 4. Okay. Let us check options. See what I am writing here. Check options. Check options for P on both tangent and curve. Let me explain. Now we know that the point has to lie on this x plus 2y equal to 3. Okay. And the curve also. What is the standard procedure? The standard procedure is from this x is 3 minus 2y, put that in the equation of curve, you get a quadratic equation in y, one root is definitely 1, find the other root and so on. Now this is shortcut method. Check options one by one. For example, option 4, 4. We will not consider that because 4, 4 is not satisfying x plus 2y equal to 3. Then consider option B and then C and then D if required. So tell me what is the correct option. I hope you understood this. What about option B? Minus 1, 2. Minus 1, 2. Minus 1 plus 4 is 3. True. But see whether minus 1, 2 satisfies the equation of curve or not. Let me see that. Minus 1, 2. No, it is not satisfying. So B is not the correct option. What about C? 3, 6. Not satisfying. So D must be the correct option. There is no other option than the option. I hope this is the correct answer. Sum number 10. The approximate value of tan 44 degree 30 minute given that. Clearly you have to define function as what? F of x equal to tan x. So f dash of x equal to sec square x. You have to take a equal to 45 degrees, that is pi by 4 radian. So what will be h? H will be minus 30 minute, means minus half degree, means minus half into 0.0175 radian. Now what is the formula for approximation? It is f of a plus h, approximately f of a, means tan pi by 4, which is 1, right? Then plus h into, but h is minus half into this. And what is y2? Because sec pi by 4 is root 2, sec square is 2. So tell me, I think the correct option is D, Delhi. See the difference. D is 0.9825. So correct option is D, Delhi. Now the next topic is an important one, definite integral. Let me explain. Suppose the function y equal to f of x is continuous on closed interval ab, and suppose integral f of x dx is nothing but phi of x plus c, then integral, how to read this, integral f of x dx from a to b. This is basically from x equal to a to x equal to b is defined as phi of x from a to b. First we put upper limit, so phi of b, minus we put lower limit, phi of a. This is called as fundamental theorem of integral calculus. I repeat this. Suppose the function y equal to fx is continuous on closed interval ab, And if integral f of x dx is phi of x plus c, then integral f of x dx from x equal to a from x equal to a to x equal to b is phi of x from a to b, which is phi of b minus phi of a. This is called as fundamental theorem of integral calculus. Now, why this is called as definite integral? Because the answer is a real number. The previous one was indefinite integral because there are infinitely many answers. Of course, two answers differ by a constant term. Now, you will observe one thing, that the constant of integration which occurs in indefinite does not occur in this case. How can we prove this? See, this is very simple. Suppose we consider phi of x plus c. Okay, phi of x plus c, x goes from a to b. So first we replace every x by b. So it is what? Phi of b plus c minus, now we replace every x by a, so phi of a plus c, see as it is. Now open the bracket, see what you get. So this is nothing but phi of b plus c minus phi of a minus c, and that is why the constant of integration does not appear in case of this, and that is why it is called as definite integral. Okay. Now, what does this represent geometrically? This is interesting. We will be discussing the same in the next topic, which is applications of definite integral. This is the curve y equal to fx. This is x equal to a. This is x equal to b. Now, what does integral a to b fx dx represent geometrically? It represents area of the region. Which region? Bounded strictly by the curve y equal to fx, x-axis, and which two lines? X equal to a and x equal to b. Okay. Now there are three simple theorems, like in case of limits, limit of sum of limits, then derivative of sum of derivatives. Then in case of indefinite integral of sum is sum of indefinite integral. Same in case of definite integral. So the three theorems, first for sum, second for difference, and third one for constant into function, is that constant into definite integral of that function. So these three theorems are applicable in this case also. So just see this. The fundamental theorem of integral calculus provides an easy method of evaluating integral a to b fx dx. The theorem is stated below and we have to accept this without proof. If a function f is continuous on the closed interval ab and integral fx dx is phi of x, then integral a to b fx dx, phi of x, x goes from a to b, that is phi of b minus phi of a. A and B are called as limits of integration, A being the lower limit and B the upper limit of integration. Note that the indefinite integral fx dx is a function of x, but the definite integral a to b fx dx is a real number. The definite integral does not contain the constant of integration. We can easily verify this as follows. I have already explained this. Okay. So these theorems. If f and g are integrable and k is a constant, then integral a to b f of x plus minus g of x dx is what? Integral a to b f of x dx plus minus integral a to b g of x dx. Second or third, you can say, if you separate these two, integral a to b k fx dx, where k is constant, is k integral a to b fx dx. Okay. So this is about fundamental theorem. In the next lecture, we will first discuss how integral can be expressed as limit of sum. Then we will solve sums using fundamental theorem. So we stop here.